Have a good day, children. Now let us start. Let us continue the chord properties. In part 1 and 2 we have finished two theorems. Okay, let me again revise. In part 1 we learned that the straight line drawn from the center of a circle bisecting a chord is perpendicular to it. In part 2 we learned the converse of the previous one, that is the line the perpendicular drawn from the center of a circle to a chord bisects the chord. That is what we have learned. Now we will learn the next theorem, which in our series it will be number 3. So in theorem number 3, for our convenience, don't forget the theorem has no number. You cannot refer to this theorem as theorem 3. The statement itself is reference. Okay. Now in this we will be learning something about equal chords. Okay. So here the theorem states equal chords of a circle are equidistant from the center of the circle. Okay. Now what does this mean? If there are two chords which are equal in length, equal chords means the chords are equal in length. So let us say AB and CD are two chords which are equal in length. Then this theorem states that they will be equidistant from the center of the circle. Now what does equidistant means? The perpendicular distance. Okay. So the perpendicular distance of the chord from the center will be equal. That is the distance, perpendicular distance. So that means let us draw a diagram and understand. What we have? Two chords which are equal. So let us draw a circle first. This is the circle in which the circle center is O. So we have a circle with center O. Now there are two chords which are equal. So let us call them AB and CD. So suppose AB is one chord and CD, say CD is another chord. What is given to us or what is known to us? Equal chords, means AB and CD are equal in length. Okay. So what is given to us? Given is chord AB is equal to chord CD. That is what is given in these two words, equal chords. Okay. Now according to this theorem, what the theorem states? They will be equidistant from the center of the circle. So center of the circle is O. What is equidistant meaning? Means the perpendicular distance of each of the chord from the center will be same. Okay. Then only we will call it equidistant. So let us see, let me draw it properly. Suppose this is the center as we have taken O. Now perpendicular distance means, the equidistant means perpendicular distance. Perpendicular distance means we have to draw perpendicular. So let us draw from O a perpendicular on the chord AB, say OP. Okay. And let us draw a perpendicular, say OQ on chord CD. Okay. So according to this theorem, OP will be equal to OQ. Okay. So let us verify whether they are equal or not. This theorem says they will be equal. Okay. So now what we have to prove? OP is equal to OQ. And what is OP and what is OQ? They are the perpendiculars drawn from the center of the circle to each of the chord AB and CD. What is given to us? Chord AB is equal to chord CD. Now what we have to prove? OP is equal to OQ. Okay. So in order to prove that, let us join again OB and OD. Okay. So now let us write what we need to prove. We have to prove, already it is proved, we are just showing you that it is true. Okay, it is already proved that it is universally true. Now what is it that we want to verify? Whether if chord AB and chord CD are equal, whether they are equidistant or not. So in order to prove that, what we have to see, whether OP is equal to OQ or not. So to prove OP is equal to OQ. If that we prove, then we can accept yes, the chords are equidistant on the center. Now in order to prove that, we have done some construction, and that construction is join OB and OD. So whatever we do in construction, you also must do it in dotted lines. Okay. So now we have to prove OP is equal to OQ. Again, to prove that, we will consider these two triangles and we will try to prove them congruent. But before that, we will make use of our previous knowledge. Now what is our previous knowledge? The perpendicular drawn from the center of a circle to a chord bisects the chord. So we are using that theorem. So here you will use this theorem only, which is that is the perpendicular drawn, because here we know that OQ and OP are perpendicular. They are not bisectors. We know that they are perpendiculars. So we will conclude from the previous theorem that we learned, that the perpendicular drawn from the center to a chord bisects the chord. Okay, here we will not write that other theorem, that is the line joining the center of a circle to the midpoint of the chord or bisecting a chord is perpendicular to it. That theorem is not applicable. Here what is applicable? The perpendicular drawn from the center of a circle to a chord bisects the chord. So that theorem we will use, and we will say that P is midpoint of AB and Q is midpoint of CD, or AP is equal to PB and QD is equal to QC, that is Q is the midpoint of CD. But we know AB is equal to CD, it is given, right? So PB is equal to QD, half of AB will be equal to half of CD. So already we know that PB is equal to QD, but we must write it properly. So I will show you how to write it. So proof. Here we are already using the previous theorem that we have learned. So we have to write it that as a reason. So now here first we will say that OP is perpendicular. Here we haven't written this point. This is already given. Okay. But equal chords of a circle are equidistant from the center of a circle. So equidistant means we need perpendiculars. So here we can add here in construction that draw OP perpendicular to AB and OQ perpendicular to CD, that we have drawn. Okay, why we have drawn? Because they told equidistant. Equidistance means the perpendicular distance, so that is why we have drawn. So now OP is perpendicular to AB and OQ is perpendicular to CD. What does these two imply? These two imply that P is midpoint of AB and Q is midpoint of CD, chord CD. Okay. Now how, from which it follows from which theorem? The previous theorem that we have learned. Or you may also write it instead of midpoint, you may say OP is bisector of AB and OQ is the perpendicular bisector of CD. Now how did we conclude this? From our knowledge of our previous theorem. And what is the previous theorem statement? It states the perpendicular from the center of a circle to a chord bisects the chord. Okay, you remember this? We have learned in our previous parts. Okay, so according to this theorem only, we are able to conclude that P is midpoint of AB and Q is midpoint of CD. Why? Because OP is perpendicular to AB and OQ is perpendicular to CD. Now consider triangles OPB and OQD. Okay, so okay, now consider triangle OPB and triangle OQD. Okay, now in this we already have proved P is midpoint of AB and Q is midpoint of CD. Means what? This implies what? That PB is equal to QD. Why? Because what is PB? Half of AB. And what is CD? Half of CD. QD is half of CD. And the reason why the halves are equal? Because chord AB is equal to chord CD. That is what is known to us, equal chords. Okay, so their halves automatically will be equal. Okay, so PB is half of AB and QD is half of CD. So therefore PB is equal to QD. And that follows what is the reason? Chord AB is equal to chord CD. And how did we decide that P and Q are midpoints? From the previous theorem, the perpendicular from the center of a circle to a chord bisects the chord. Okay, now we will consider these those two triangles. Now in this we have already proved PB is equal to which one? QD. Okay, so PB is equal to QD we have proved. Now angle OPB is equal to 90 degree, angle OQD is 90 degree by our own construction. So angle OPB is equal to angle OQD is equal to 90 degrees by the construction we have constructed. Okay. Now what else is there? We have proved that this is 90 degree. We have proved this is equal to this. Now we have OB is equal to OD. Why? Because radii of the same circle. So OB is equal to OD, radii of the same circle. Okay. So now this implies that these two triangles are congruent. By which property? This is the hypotenuse, then this is one side and 90 degrees. So RHS. So therefore triangle OPB is congruent to triangle OQD by RHS property. Okay. So this implies if they are congruent, the corresponding sides will be equal. So OP and OQ are corresponding sides of the congruent triangle, so they will be equal. So this implies OP is equal to OQ, corresponding sides of congruent triangles. So that is what we want to know, where to verify. We have verified that OP is equal to OQ. And what is OP and OQ? They are the perpendiculars or perpendicular distance of the chord AB and chord CD from the center. So that means if they are equal, that means the chords are equidistant. So we have proved, it is verified that what the theorem says is true. These are already verified. We are doing it just to confirm to you. You should not have any doubt whether these theorems are really true or not. So that means now what does it imply? That if you know that two chords are equal in a circle, so automatically you can conclude that they will be equidistant from the center of the circle according to this theorem. So equidistant means the perpendicular distance, not any line drawn from the center, not any inclined line, they will not be equal. Equidistant means the perpendicular distance of each of the chord from the center of the circle will be equal. So now I hope it is clear. Let me revise once again what we have learnt. Equal chords of a circle are equidistant from the center of the circle. So if you know the two chords in a circle are equal, then you can conclude that they are equidistant from the center O of the circle. Is it clear, children?